Okay, you all should be on page 28. Last thing that we are talking about for the SAT is counting. So an example of this is if you have 4 pairs of pants and 5 different tops, how many outfits do you have?
Wait, what?
If you have 4 different pairs of pants, 5 different tops at home, how many outfits can you make? 20. So that's kind of what we're going to be looking at today. If you are someone who signed up for Human Endeavors next year, you're going to be doing some counting. So we're going to start out with an investigation, something where you guys are going to try to come up with the answer. Suppose that 3 towns, Ashbury, Brampton, and Carmichael, are located in such a way that 2 roads connect Ashbury to Brampton and 3 roads connect Brampton to Carmichael. How many different routes can one travel from Ashbury to Carmichael traveling via Brampton? It is a lot of words. Before you even jump in with numbers, what would be a good idea? Draw a picture. So try that right now. Take 30 seconds or a minute, come up with a picture, and try to come up with a calculation. You have Ashbury, Brampton, Carmichael. So draw those 3 towns.
3 towns? Or
3 towns, yep. Maybe label them so you know what's what. Can you talk to the person next to you, show the person your figure, and see if you all have a similar idea? If you both have a figure of some type. Okay, here's my figure. You should have 3 different towns, Ashbury, Brampton, Carmichael. You should label them, otherwise you're going to get a little lost. 2 roads connect Ashbury to Brampton. So here's one road, here's the other road. 3 roads connect Brampton to Carmichael. So 1, 2, 3. How many different routes are there from Ashbury to Carmichael going through Brampton? So we could go this way, 1, 2, 1, 2, 1, 2. So that's 3 different routes. 4, 5, 6. So we get 6 different routes. Now, is there a calculation we could have done to come up with 6 besides actually drawing out all the possibilities? So 2 routes here multiplied by the 3 routes here will give you 6. So 2 here, 3 here gives you 6. Okay, that is the idea behind the counting principle. If you are looking for the number of ways to do something, you're allowed to multiply. So I'm not sure how I'm going to put that into words. I'm just going to write the big word multiply. Okay, we're going to go through a few examples together. Example 1. An ice cream store offers 3 types of cones and 31 flavors. How many different single scoop ice cream cones is it possible to buy at this store? Okay, first thing you're going to decide is how many decisions do you have to make. If we're walking in and buying an ice cream cone, what decisions do we have to make, or how many?
3 different.
Miranda?
You have to make the decision on what cone to get because that's free there. And then there's 31 different flavors,
So 2 decisions overall. What kind of cone do I want? What kind of ice cream do I want? So this first spot is going to represent the cone that I choose. Second spot is going to represent the ice cream that I choose. How many options do I have for the cone? 3. Options for the ice cream. 31. What do I do with those two numbers? Multiply. 3 times 31? 93. Okay. Example 2. In a certain state, automobile license plates display 3 letters followed by 3 digits. How many plates are possible if repetition of the letters is permitted? Okay, so if I need a spot for every decision, how many decisions or how many places are there going to be here? 6. Donovan, where do you get 6?
The 3 letters and 3 numbers.
Okay, 3 letters followed by 3 numbers. So I need to pick 3 letters, then I need to pick 3 numbers. So these first 3 represent the letters I need. Next 3 represent the digits or the numbers. How many options do I have for the first letter? 26. Okay, now we're saying repetition is allowed. So how many options do I have for the second letter?
26.
Still 26. And the third letter? 26. How many options do I have for the first digit?
Isn't it infinite? It's 9.
Is it 9 or 10?
It's 9.
You've never seen 0 on a license plate before? 0's definitely allowed. There's 10 digits. 0 through 9. Again, repetition is allowed, so you're going to have 10 and 10. You are now multiplying all of these. I believe it's something like this. A little over 17.5 million license plates. Now, is this realistic?
No.
Is repetition going to be allowed?
No.
Probably, but what license plates might we come up with this way? Like what's one license plate that probably wouldn't be used?
ABC 1, 2, 3.
Right, ABC 1, 2, 3. Is that license plate used? Probably not. Or AAA 000. What else do we have to be careful of with license plates?
Repeats of the same license plate numbers.
Yeah, repeats of the same license plate.
Bad words.
Yes, curse words.
Oh.
So all of these are not used. So realistically, real life, even if you calculate how many license plates are possible, at least a quarter of them are not going to be used. Either because they're too simple, ABC 1, 2, 3, or because they are not appropriate in some way, shape, or form. Okay, this is going to change now if I do not allow repetition. We still have 3 letters, still have 3 numbers. How many options do we have for the first letter? 26, 25, 24, because I'm not allowing repetition. And then 10, 9, 8. And again, you're multiplying. I got about 11.2 million. You guys agree?
Mm-hmm.
Okay. Is this something you've seen before?
Yeah.
Maybe vaguely? Okay, in how many different ways can a race with 6 runners be completed?
6.
Okay, how many different spaces do we need?
2.
What do the spaces here represent? So up here, they represented the letters and numbers we were choosing.
The ways for win and the runners.
Who's coming in when? So I have someone who comes in first place, someone who comes in second place, third, all the way down to 6th place, because there's 6 runners. How many options do I have for the person that comes in first place?
All of them.
6, right? Anyone could win. What about second place now?
5.
5. And then 4, 3, 2, 1. So there are about 720 ways in which the race could be completed. Okay, flipping the page. Okay, this is a difficult one that we're going to do together. 5-letter words are formed using the letters A, B, C, D, E, F, and G. How many such words are possible for each of the following conditions? Do you know why I put words in quotes?
Just it's a combination of letters.
Right, any combination of letters regardless of whether or not it forms a word. So if I have 5-letter words, how many spaces am I going to write out? 5. Just go ahead and do that for all of them because they're all going to be like that. If no condition at all is imposed, how many options do I have for the first letter?
Let me see.
I'm only using these letters, though.
7.
7. How many do I have for the second?
7.
7. 7. What is a more efficient way of typing that to my calculator?
7 to the power of
7 to the 5th. Which gives me 16,807 words. What happens if no letter can be repeated? How many options for the first one? 7. The next one? 6, 5, 4, 3. Then we get 2,520, so much less words. Okay. What if each word has to begin with the letter A?
1, 7, 7, 7, 7.
So only one option for the first letter, because I'm saying it has to be an A. The rest of the letters, I don't care. So 7, 7, 7, 7. And again, you're multiplying. This ends up being 2,401. What if the letter C has to be in the middle?
7, 7, 1, 7, 7.
So C has to go there, only one option there. 7 options for the other spaces, which again will be 2,401. It's exactly what we did ahead. What happens if the middle letter has to be a vowel?
2.
So 7, 7, 7, 7. There are 2 vowels, either A or E. Anybody know what this is going to be?
Double that.
Yeah, double this. So it'll be 4,802.
It's very confusing.
Okay, 5A. There are 4 people running a race. How many ways can you award medals for first and second place? How many spaces do we need?
2.
2. Whoever comes in first, whoever comes in second. What goes here?
4.
4. 3. 4 people can come in first. Once someone comes in first, the rest of them can come in second. There are 12 such ways. Now, not in example 1. Change that to 5A. Consider the race described in example 5A. Suppose now that you award the same medals to the runners who finish first and second. How many ways can you award these medals? So here's my question for you. Is this the same question or the same scenario? Real life wise, is it the same?
Scenario.
Is it the same scenario in real life?
No, because it doesn't say how many runners there are.
It's exactly the same race. Still 4 people.
Oh, it says that. Oh, never mind then.
Okay, so it's not going to be exactly the same because in 5A, if I win first place or I win second place, those are 2 different medals. In example 5B, if I come in first or second, I'm getting the same medal regardless. So coming in first is exactly the same as coming in second in terms of the medal I get. So does that make sense that these are not the same question? Okay, this one you cannot approach the same way that you did 5A. So any ideas if we don't actually know how to calculate this? What did we do with the very first example on the previous page when we didn't know how to do the calculation? We drew a picture. So we have 4 runners. Let's call them A, B, C, and D. we're looking at all the ways that people can come in first and second together. That would be runners A and B, A and C, A and D. Now, do I have to reverse all of these and consider BA also?
Yes.
So this is runner A comes in first place, runner B comes in second place.
No, you don't have to because they both get the same.
They both get the same medal, so it doesn't matter if they come in the reverse order. So what else am I missing? If I did AB, AC, AD, BC, BD. Anything else I'm missing? CD. Anything else? No, so how many different ways? 6. Okay, questions before we keep going? Donovan.
Would you write like 12 ways or like on there to go to the unit kind of thing?
It would be nice, yes. Overall, I'm fine if you don't, but it would be nice. Do we all have calculators out? Because what we're doing next, you're going to need a calculator for. Okay. These two, 5A and 5B, were examples of the next thing that we're going to learn, which is called permutations and combinations. So a permutation is an arrangement of objects in which an order does matter. By example 1, I mean 5A. So permutation, order matters. So it matters if you come in first versus second place, because you're going to get a different medal. A combination is an arrangement of objects in which order does not matter. So this would be number 5B. So in 5B, if I come in first or second, I get the same medal regardless. Doesn't matter which place I actually come in. Does that make sense, the difference?
Yeah.
Okay, we're going to read these two, and then I'll show you how to do the calculations in a minute. 7 bands have volunteered to perform for a benefit concert, but there is only enough time for 3 to play. How many lineups are possible? Now, I'm telling you that this is a permutation and order matters. Contextually, why does it matter the order that the bands are in?
Because only 3 can play?
Only 3 can play. What else? Don't people sometimes come only to listen to one band? Maybe they're not going to listen to all 3. So they might come for the first band, they might come for the band at the end, they might come in the middle. So the order the bands play are different, right? If I'm printing up a playbill, or whatever you call it for a concert program, if I'm printing up a program, I have to list the order that they're in. Yes?
Yeah.
Guys, you're just staring at me, so I have no idea if you understand what I'm saying.
Yeah.
Yes.
We do? Great. Next one. An election ballot asks voters to select 3 city commissioners from a group of 6 candidates. And how many ways can this be done? Now, in this case, does it matter the order in which you are chosen to be a city commissioner?
No.
No, either you got chosen or you didn't. Doesn't matter the order that you got chosen in. So is it clear the difference here? One order matters, one order doesn't? Okay. The way that you denote this is a permutation is with a big P. The way you denote that this is a combination is with a C. The first number is how many options you have. So out of the bands, how many do I have to choose from? 7. And out of those seven, how many am I choosing? 3. Okay, this we actually already know how to do. I have 7 options for the first band, 6 for the second band, 5 for the next band. Right, you guys already know how to do that? Okay, so that gives us 210. Now, would you like to know how to do this on the calculator? Good, because I'm going to show you anyway. Okay, you are going to type in that 7. You're going to go to Math, go over to PRB. What do you think PRB stands for? Probability. You're going to go down to that NPR one, and then you're going to plug in 3 and hit enter.
Got 210.
We did get 210. Okay. Example 7. Before I show you how to use the calculator, how else could you figure out how many ways you can choose 3 commissioners out of 6?
Groups, like list them, like list each candidate down and then.
Yeah, we could write all the candidates down. Is that going to be efficient? No, that's why we're using the calculator. So again, this number is how many I have to choose from. How many do I have to choose from in this case? 6. So there's 6 candidates, and I'm choosing 3 city commissioners. It's going to work a very similar way. You're going to hit 6, go to math, probability, this time choose the one with a C, and then you'll put in 3 and hit enter. So in this case, there's only 20 different groups that we can choose for the city commissioners. Okay, we are going to do one example together, and then you're going to do 9 and 10. One thing that's really important, for both permutations and combinations, objects cannot be repeated. That is really important. So if I allowed the possibility of 2 bands, if one band to play twice, that's no longer a permutation. So no object can be repeated. Again, it's not example 3. Sorry. Okay, example 8. In a production of Grease, 8 actors are considered for the male roles of Danny, Kaniki, and Marty. In how many ways can the director cast the male roles? So first thing we have to ask ourselves is this a permutation or a combination?
Combination.
Permutation.
Okay, I hear both. So, what do we think and why? Chris, what do you think?
I think it's a combination because it doesn't matter who goes to Danny, who goes to Kennedy, and who goes to Marty.
Okay. Lizzie?
I think it's a permutation because although it's all like roles, they have like different there's like for example Danny is like a really important character and like
Right.
the other 2 are like less significant, so they're different.
Yes, I would agree. This is a permutation. If you're chosen for Danny, that's different than being chosen for Marty. The people who are auditioning have specific roles that we want. Bless you. So, permutation. How many people do I have to consider?
8.
8. And then I'm choosing 3 of them. So again, I could say there's 3 roles, 8 person for the first one, 7 for the second, and 6 for the third one. That's one way of calculating it. The other way would be to type in 8 and go to NPR and then do 3. So we get 336 ways that we can cast those roles. Okay. You try example 9 real quick. Example 9, you can skip this second part. So just do the first part of 9 and then take a look at 10.
Does it matter if you switch up like for 9 like the 12 and the 6 in the calculator?
Yes.
For 10, can you have 2 of the same toppings?
I'm gonna say no. You're gonna have 2 different toppings. Check your answer to 9 with the person next to you, and then start discussing 10.
Did you really say no? I just like 25 toppings. Yeah, because you can choose 2 toppings. Yeah, I'm not sure. It's just guess.
Okay. It sounds like we want to go over this because
Yeah.
you're not discussing it very much. Problem 9, is this a combination or a permutation? Combination. What number goes to the left?
12.
12. I have 12 people to choose from. I'm choosing 6 of them. I didn't actually do this. 924?
Yes.
I agree, 924. Okay, let's see how we did on 10. You are ordering a pizza from Pie 5. You have the following options to choose from: 4 crust, 7 sauces, 5 cheeses, 25 toppings. Assuming you must choose 1 crust, 1 sauce, 1 cheese, and 2 toppings, how many different pizzas are possible? Okay, I have to choose 1 crust, 1 sauce, 1 cheese, and 2 toppings. Now I'm going to keep those together because they're both toppings. How many options do I have for the crust?
7. 4.
4. 7 choices for sauce. 5 choices for cheese. What do we do with the toppings part?
You multiply by 2.
Miranda?
So the first one would be 25.
Okay.
The second one would be 24 because we can't have a repeat of the same topping.
You guys agree?
It says 2 toppings,
Yeah.
and I'm assuming it means different toppings.
Yes, it does mean different toppings.
That makes a lot of sense.
Okay, here's the issue with that. When we do 25 times 24, this is saying, like we did up here, anytime you multiply an order, that's saying that order matters. Does it matter the order that I choose these toppings?
Oh.
No.
So you choose 1 twice?
So that does not work.
Shoot.
Nathan?
Multiply 25 by 2? No.
Ignoring everything else, how can I figure out just the number of ways I could choose 2 toppings?
25.
That's the real question. How do you figure out the number of ways to choose 2 toppings from 25?
Use the equations that we learned.
Yeah. Which one is it?
Combination.
It's a combination, right? Order doesn't matter. It doesn't matter the order that I choose these toppings. So for those toppings, it's a combination. I have 25 options, and I'm choosing 2 of them. So there are 300 ways for me to choose those 2 toppings. I still then have to multiply by 5, by 7, by 4. So there are about 42,000 different pizzas. Does that make sense now?